Mr. Clelland here for Clelland Maths. This is your ultimate Higher Maths Prelim Special for 2025-26. 2 hours, full topic coverage, and it goes through every single thing in your exams. Hopefully you find this useful. Just get the PDF on the website. And remember, tomorrow on Sunday at 3 o'clock, we have got our members-only live stream, Prelim Special, where we're doing lots of stuff for your prelims. So if you want to get on that, just click the link and join now. Also, we've got our app.clellandmaths.com. I know a lot of you have been asking, so I thought I'd just tell you, we're going to be getting on that and getting the higher math stuff on there. Hopefully you enjoy this video. Just give it a like and a share. Thank you very much, and Merry Christmas. SQA Higher Maths 2025 Paper 1 Question 2. Find the equation of a perpendicular bisector between 1, 4 and 9, 10. So perpendicular bisector means you need to find the midpoint first and then use m1 times m2 equals minus 1 for your gradient. So let's do midpoint of a and b. So that's when you add the points and divide by 2. Average them out. 1 plus 9 over 2 and 4 plus 10 over 2. 1 plus 9 is 10. So that's 10 over 2 and 14 over 2. That gives me 5 and 7. So there's my midpoint, and then I want my gradient of a and b. So 10 minus 4 on the top and 9 minus 1 on the bottom. 6 over 8, which simplifies to 3 over 4. So we can say that the gradient of our perpendicular is equal to minus 4/3 straight away, because m1, m2 equals minus 1. So we've now got our point, 5, 7, and our gradient, minus 4/3. So once again, y minus b is mx minus a. So then we can just take the 3 up, equals minus 4x minus 5, 3y minus 21, minus 4x plus 20. Now you can't really leave it like that, so I'll take the x's to the same side and take the numbers to the same side, so you get 41. That's one option. Or you could have 3y plus 4x minus 41 equals 0. Or really, if you really wanted to have y equals, it would be minus 4 over 3x plus 41 over 3. I probably wouldn't bother leaving it like that. And we're done there. Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and Higher Maths. These are just £5.59 when you use the discount code ClellandMaths at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code ClellandMaths. The links are in the description and down below. SQA Higher Maths 2023 Paper 2 Question 1. Triangle PQR has these vertices. Find the equation of the altitude from P. Well, what they're drawing in it's a right angle. So if I can find the gradient of QR, I'll know the gradient of the perpendicular. So part A, the gradient of QR. I've got 3 minus 8 on the top over 13 minus 2. y2 minus y1 over x2 minus x1. 3 take away 8 is negative 5. 13 minus 2 is 15. That gives me minus 1/3. And therefore, the gradient of the perpendicular must be 3, since m1 times m2 equals minus 1. And you always need that statement. So now we can use the point P to get the equation. So P is 5 minus 1. So I can use y minus b, y minus 1 equals 3x minus 5. So y plus 1 is 3x minus 15. And therefore y must be 3x minus 16. And we're done there. Part B, calculate the angle beside PR makes for the positive direction of the x-axis. Well, we know that gradient equals tan theta. So we need the gradient of PR. So let's look at P and R. We've got R, 3 minus 1 on the top, over 13 minus 5 on the bottom. That gives me 4 over 8, which is 1/2. So our tan theta equals 1/2. So the inverse tan of 1/2 equals, using a calculator, you get 26.565 or 26.6 degrees. And we're done there. SQA Higher Maths 2025, Paper 2, Question 1. The triangle ABC has these vertices. Find the equation of the altitude, then the median, then the point of intersection. Fairly standard stuff here. Altitude for B, it says. So there's B there. So my altitude is at right angles to AC. So I need the gradient of AC. So for part A, the gradient of AC is minus 24 minus minus 14 all over 21 minus minus 9. Use a calculator anytime you want, but that is minus 24 plus 14 is minus 10 over 30, which is minus a third. So that means the gradient of our perpendicular is equal to 3 as m1, m2 equals minus 1. And then the point I'm using is b, which is 920. So y minus 20 equals 3x minus 9. Y minus 20, 3x minus 27 then. So y equals 3x minus 27 plus 20 is minus 7. And we're done there for part A. Part B, the equation of the median for A. So a median cuts the opposite side at, well, 50-50. So I need the midpoint of BC. So I've got 920. B is 920. And C, I think, was 21 minus 24. So the mid of BC, 9 plus 21 divided by 2. And 20 minus 24 divided by 2. 9 and 21 is 30, so that makes 15. 20 minus 24 is minus 4, so that makes minus 2. So we get 15 minus 2 as our midpoint. So now we need the gradient between A and M, because we're needing to go from here to here, which is M. A is minus 9 minus 14. So the gradient between, let's call midpoint M, the gradient between A and M is y2 minus y1, so I'll just do minus 14 minus minus 2 over minus 9 minus 15. Minus 14 plus 2 is minus 12, and minus 9 minus 15 is minus 24, which leaves a half. So then use a point A for A and B. I'll just use this one. Y minus minus 2 equals a half x minus 15. Take the 2 up then. Y plus 2 equals x minus 15. So we've got 2y plus 4 is x minus 15, or 2y minus x equals minus 19. And that's an acceptable way to leave it. You can leave it as y equals if you want, which might be handy for this question, but I'm not going to. I'm going to do it a different way. So question C, find the point of intersection between the median and the altitude. I've got two equations, y equals 3x minus 7. And I've got 2y minus x equals minus 19. What's the ways to solve this? You could sub the y in for x here. You can make y here and then make them both equal, or you could do it like National 5 Maths. I'm going to do it like National 5 Maths because I've got a feeling a lot of us would. So I've got y minus 3x equals minus 7 for the first one, and 2y minus x equals minus 19. So I can just times the top one by 2, say, to get 2y minus 6x equals minus 14, and 2y minus x equals minus 19, and then just take away because the signs on the y are the same. What's your signs here? Minus 6x minus minus x is minus 5x, and minus 14 minus minus becomes plus. So it's minus 14 add 19. 19 minus 14 is 5. So therefore x is minus 1, and then we just sub into one of our equations, where we already had y equals 3x minus 7. So that's just 3 times minus 1 minus 7 minus 3 minus 7 is minus 10. Our point of intersection is minus 1 minus 10, and we're done there. SQA Higher Maths 2025, Paper 2, Question 9. A sequence satisfies the recurrence relationship un plus 1 equals mun plus 4, and m is a constant. The sequence approaches a limit as 10 as n goes to infinity. Determine the value. I'm still going to save it. The limit exists implies that minus 1 is less than m is less than 1. I'm going to work at my m anyway. And then we've got L equals b over 1 minus a. So b is 4, 1 minus m, and that equals 10, it says. So solving that equation, 10, 1 minus m equals 4. That's 10 minus 10m equals 4. So minus 10m equals 4 minus 10, which is minus 6. So m is minus 6 over minus 10. Simplify that, minuses disappear, minuses cancel, then we divide by 2. 6 divided by 2 is 3, 10 divided by 2 is 5. So there's our m. Part B, u1 is 19, find u0. So un plus 1 equals 3/5 un plus 4. And u1 equals 19. So we can just say that if we had u1 here, it would give me u2. If I've got u1 here, it will give me u0 here. So we can just say that 3/5 u0 plus 4 equals u1, which is 19. So 3/5 u0 equals 15. So 3u0, u0 is 75, 5 15ths. So u0 is 75 over 3, which is 25. And we're done there. SQA Higher Maths 2024, Paper 1, Question 2. A sequence is defined by a recurrence relationship. Un plus 1 is a fifth, un plus 12, and u1 is 20. Calculate the value of u2. Okay, so u2 is a fifth, u1 plus 12, but u1 is 20. So that's a fifth times 20 plus 12. A fifth of 20 is 4. 4 plus 12 then is 16. And we're done there. Part B, I. Why does it approach a limit as n goes to infinity? Because minus 1 is less than a fifth, which is less than 1, therefore the limit exists. Part 2, calculate this limit. Well, I use b over 1 minus a. So that is a and that is b. So that's 12 over 1 minus a fifth. That's 12 over 4/5. That's 12 times the reciprocal of 5/4. 12 divided by 4 is 3 times 5 equals 15. And we're done there. SQA Higher Maths 2019, Paper 2, Question 4. It says, in a forest, the population of a species of mouse is fallen by 2.7% a year. To increase the population, scientists plan to release 30 mice into the forest at the end of the year. It says UN is the estimated population at the start of April, n years after the population is first estimated, and it knows that UN and UN plus 1 satisfy this recurrence relationship. State the values of A and B. So for part A, it's really about pulling out the information from the question. So let's have a look at this. We have got it's falling by 2.7%. So to work out A is going to be the percent times UN, but what's left over? So it's 100% minus 2.7%. That gives me 97.3%. So A is equal to 0.973. And then B, we plan to release 30 mice into the forest at the end of each year, so B is 30. And we're done there. Question B. Explain why the estimated population of mice will stabilize in the long term. So it mentions stabilizing, so it means a limit exists. So we can say a limit exists since minus 1 is less than 0.973, which is less than 1. And that's all we need to say. Step 2, calculate long-term population of nearest 100, and now let's find the limit. So for part 2, L equals B over 1 minus A. So we'll just plug our numbers in. B is 30, then it's 1 minus 0.973. 30, over 0.027, which is 111.11, 111.11, or to the nearest 100, 1,100. And we're done there. SQA Higher Maths 2019 Paper 2 Question 8 on functions and inverse functions. A function f is given by f of x is a cube root of x plus 8. It tells you the domain is 1 between 1 and 1,000 and it's a real number. If inverse function is this, find the inverse function. So how I always do this is I let y equal the cube root of x plus 8 and I'll just rearrange that to make x the subject. So y minus 8 equals the cube root of x. Cubing both sides then, I get y minus 8 cubed equals x, and I then straight away can just jump in and say that the inverse function of x then is equal to x minus 8 cubed. I just swap the y for an x. Do not write at this point here, this is very important. Do not then write y equals nx there because you've already said that y equals this, so it doesn't equal that with an x in it. Just jump from here to here and you're done. Part B, state the domain of the inverse function. The domain of the inverse function is the same as the range of the original function, okay? So let's check the range of f of x. So I'll just write it down. Range of f of x equals domain of the inverse function. In becomes out and out becomes in. So what's the range? Well, the range of f of x is just putting in f of 1. Well, that's the cube root of 1 plus 8, which equals 9. And f of 1,000, which is the highest number it can be, is the cube root of 1,000 plus 8. Well, 10 times 10 is 100, times 10 is 1,000, so that's 18. So therefore, the domain of the inverse function is 9 is less than or equal to x is less than or equal to 18. And we're done there. It's between 9 and 18. SQA Higher Maths 2025, Paper 2, Question 12. Functions f and g are defined as a set of real numbers by that. Find an expression for h of x, which is f of g of x. Okay, part A, f of g of x means in f, put in g every time you see an x. So f says x to the power of 5. So that is g of x to the power of 5 plus 3. What is g of x? 1 minus x cubed. So I put 1 minus x cubed here. That's to the power of 5 plus 3. There's not much else I can do with that because it's spanning a fifth bracket beyond us. So we've got 1 minus x cubed to the power of 5 plus 3. Now part B says find h dash x. So it's differentiation then. Well, chain rule. 5 comes down to the front. 1 minus x cubed stays where it is, and I take away 4. The 3 is going to disappear, of course. And now I need to break the chain. 1 minus x cubed, I need to differentiate it. So x cubed becomes 3x squared, and it's a minus. So it's times by that. 5 3s is 15, so minus 15x squared, 1 minus x cubed to the power of 4, and we're done there. SQA Higher Maths 2025, Paper 2, Question 4. The function g is defined as g of x is x minus 4 cubed. Find the inverse function. There's two ways to do this. I'll show you both if you fancy. So the first method is the way I prefer nowadays, which is to say that g of g inverse of x equals x. So if you just sub in inverse of x, inverse function into x, you'll get it. So that gives me x becomes inverse function of x minus 4 all cubed equals x, I'm saying. So I need to get rid of that cubed, so I can say the inverse function of x minus 4 just equals the cube root of x, and then I've got it. Inverse function of x equals the cube root of x plus 4. And we're done there. Let me show you the alternative method. The alternative method is, let's start with our function again. G of x is x minus 4 cubed. You say, let y equal x minus 4 cubed, and then make y x the subject. So the cube root of y is x minus 4. The cube root of y plus 4 equals x. And then immediately you just say then inverse, it's not f, it's g in this case. The inverse function of x is the cube root of x plus 4. But be careful with this method. Don't ever change that to a y again because you'll lose a mark. and you may need a statement at the start. I never use this method. I prefer this method nowadays. I think it's cleaner. SQA Higher Maths 2019, Paper 1, Question 10, Graphs of Related Functions. The diagram shows the graphs of f of x and kf of x plus a. We have to find the values of a and k. So where's our f of x? It's this one here. And kf of x is the other one, plus a. So that's flipped upside down. And then it's maybe moved up or down. So to work out a, first of all, just compare it on this bit here. That's 0, 0, and that's 0, 3. It's clearly moved up by 3. Even if it's flipped upside down, it's still moved up by 3. So a is equal to 3. So we can just write down 3 straight away, no problem there. Now we need to find our k. Well, we know it's flipped upside down, so we know straight away it's negative. And how much? Well, just imagine if you flip this graph upside down, then you will be kind of drawing it like this. So this point here, 2 minus 1, will become 2, 1. So let me just take a note of that. That would kind of go up and become 2, 1 when it's upside down. But then we move up to 5. Now, even if I add 3, I don't get 5. So 2 times 1 is 2, plus 3 is 5. So that means k is minus 2. And we're done there. SQA Higher Maths 2025, Paper 1, Question 5. The diagram shows the graph of f of x with stationary points at 0, 3, 4, 0. And on the diagram in your answer booklet, sketch the graph of f of minus x plus 3. Now, this is where I think some people will make a mistake. The minus is not in front, so it's not flipping that way. The minus is stuck here, which means we're flipping that way. It's a y-axis flip, then add 3. So looking at our points, let me just draw a graph for this. Got a y-axis and an x-axis. So looking at minus 2, if that goes over the y-axis, it becomes 2. But then I need to add 3, so it becomes 2, 3. So I can just note a point, 2, 3. Looking at 0, 3, well, when you flip it on the y-axis, it's still 0, 3. But I'm adding 3, so it's plus 6, 0, 6. So I can just put 0, 6 up here. And then the last one, 4 is going to flip over to be minus 4, but then I need to add 3, so it's somewhere over here. Just draw that nice and neat. Minus 4 add 3 will be in line with 2, 3. So probably somewhere about there. It's probably not to scale that, so what I'll probably do is move it out a little bit to put it over there and just make my axis a bit bigger. Minus 4, 3. But you get the idea. Now you just draw it in, watching where the turning points are. So 0, 3 was that one. So that's 0, 6. So that's that side. And then this one was the 4, but it became minus 4. So there's my turning point there for that bit. Connecting up to here, turning back round, and just going down. Now you can't quite tell where it cuts the x-axis, so that's fine. Now my curve's a bit messy there, so I'm just going to neaten that up. But other than that, that's it. So just a nice neat curve if you can. And that's a little bit better. But we're done there. SQA 2022 Higher Maths Paper 1, Question 7. Triangles ABC and ADE are both right angles. It tells us that angle BAC equals Q and DAE equals R. As shown in the diagram, calculate sin R, sin Q. So we can pull some information out of this diagram by drawing some triangles. So let me draw the small one first. If I do a little sketch, we've got R here. This whole length here is 3. And the whole length on the top is 1. So by Pythagoras, 3 squared plus 1 squared equals 10. So that must be the square root of 10. We can do the same for the Q triangle if I just do that at the side. If I call this Q, then on the hypotenuse we've got root 13, and on the bottom we've got 2. So by Pythagoras, root 13 squared minus 2 squared is 13 minus 4, which is 9. So square root of 9 is 3. So nice and simple then. Determine the value of sin R. Sin R, opposite of the hypotenuse, is 1 over root 10. And sin Q, opposite of hypotenuse, is 3 over root 13. 2 marks there. 1, 2. Nothing else you're going to do there, so let's go to part B. Okay, here's determine the value of sine q minus r. Sine q minus r equals sine q cos r minus cos q sine r. From the start of the exam paper, you'll get that. So we need to work out our different things. So sine q is 3 over root 13. Well, cos r, well, we've already got our triangle here, so 3 over root 10. And minus cos q, which using this triangle is 2 over root 13. And we've got sine r, which we already know is 1 over root 10. Times in the tops of them, we get 9 over root 130 minus 2 over root 130, which is obviously 7 over square root of 130. Always double check if you can simplify that third at the end, but you can't, and you don't have to rationalise the denominator for the marks because we're not examining that. So where do you get your marks for part B? If you wrote down sine q cos r minus cos q sine r, or you implied that by doing this, you get your marks. So there's mark 1 and 2. Substituting in 3 over root 13, 3 over root 10 minus 2 over root 13 times 1 over root 10 is your second mark, and then your final mark, obviously, for working it out is 7 over root 130. So there's your final mark there. SQA Higher Maths 2025, paper 1, question 6. The diagram shows a right angle triangle with angle at Q. Find sine 2Q cos 2Q. We have a second right angle triangle, so we have to do sine 2Q minus R. So sine 2Q is 2 sine Q cos Q. So I'm going to have to know sine Q and cos Q, so I'm going to have to do Pythagoras. 5 5s is 25, 1 1s is 1, that's 26, so that's root 26. So we get 2. The sine of Q is 1 over root 26. And the cos of Q is 5 over root 26. That's a root. 2 times 5 is 10, and 26 rooted times 26 rooted is just 26. Half each of the numbers to get 5 over 13. And we're done there. I'll do part B underneath because I don't want to get too messy. Part 2, cos 2Q. Well, there's 3 things at the start of the exam paper, but I'm just going to use 2 cos squared Q minus 1 because it's the easiest one for me to use at the moment, I think. So cos Q we already have worked out is 5 over root 26. So that's 2 5 over root 26's squared minus 1. That gives me 2 times 5 5s is 25 over 26 minus 1. 2 times 25 is 50 over 26 minus, well, 26 over 26, which is 50 minus 26 is 24. And that will be simplified to a half of 24 is 12 and a half of 26 is 13. The last bit says, find the value of sine 2Q minus R. Let me just copy that down. So again, start of exam paper, angle formula for addition. We've got sine 2Q cos R minus cos 2Q sine R. Well, sine 2Q we worked out up here was 5 over 13. So that's 5 over 13. Cos R, well, I can just work that out. Opposite over adjacent over hypotenuse. Adjacent over hypotenuse is 4 over root 17. Minus cos 2Q I worked out here was 12 13ths. And sine R is 1 over root 17. So that gives me 5 times 4 is 20, 13 root 17s minus 12, 13 root 17s, which is 1 fraction is 8 over 13 root 17s. And I think we'll be happy that that is the answer. You could probably take it a step further and rationalise the denominator, but I don't really think that you would have to in this case, but I'll do it for the sake of completeness. If I was to do that, I would do 8 over 13 root 17 times root 17 over root 17, and that would just give me 8 root 17 over 13 times 17. That's 8 root 17 over 211, which is arguably not any simpler. So 8 over 13 root 17, I think, is where we're going to be stopping. Differentiating a trig function, SQA Higher Maths 2016, paper 2, question 11. Show that sine 2x tan x equals 1 minus cos 2x, and then differentiate sine 2x tan x. So part A, sine 2x tan x, well, we can change sine 2x to 2 sine x cos x, and we can change tan x into sine x over cos x. So that gives me 2 sine squared x, and the cos x obviously cancel. So then, as an aside, remember we've got a cos 2x on the right hand side. Well, cos 2x, using the expansion with sine squared x in it, is 1 minus 2 sine squared x. So we can rearrange that to get what sine squared x is. That means that 2 sine squared x, move it over to the right, equals 1 minus cos 2x. As required. Part B, f of x is equal to 1 minus cos 2x now. So f dash x, differentiating each function, 1 goes to 0. Cos, remember, goes to minus sine, so it becomes plus sine, so it's sine 2x because of minus minus. And then we need to, because of a chain rule, differentiate the inner function, which is 2, so times by 2. So we get 2 sine 2x. SQA Higher Maths 2025, paper 2, question 6. Express 5 cos x minus 9 sine x in the form k cos x plus a, where k is greater than 0 and a is between 0 and 2 pi. So we're working in radians because it mentions pi. And then solve 5 cos x minus 9 sin x equals 7 between 0 and 2 pi. Okay, so wave function first. 5 cos x minus 9 sin x equals k cos x cos a. Change the sign, k sin x sin a. So I'm now examining what's in front of cos x on both sides. Well, k cos a equals 5. And then similarly, in front of, say, sin x, well, it's minus k sin a, but it's a minus on both sides, so I can just cancel the minus straight away. So it's just k sin a is equal to 9. If you don't like that, you can just write minus k sin a equals minus 9, so k sin a equals 9. So we've got our two equations. To get our k, it's just Pythagoras. K is the square root of both the numbers squared and added. So that is 25 and 81. 81 becomes 86, 96, 106. So I've got my k. Tan a is sine over cos 9 over 5. So I do the inverse tan of 9 over 5 in my calculator, making sure my angle is in radians. Radians inverse tan 9 over 5 is 1.063697. So I think 1.064 is a reasonable place to stop. Check that it is actually a with a cast. I never skip this step. The sine equation was positive and the cos equation was positive, so a is 1.064. So that means a equals 1.064. So we've got root 106 cos x plus 1.064. And we're done it there for part A. B says, hence solve 5 cos x minus 9 sin x equals 7 between 0 and 2 pi. Well, it's the same equation, so I just make that equal to 7. Root 106 cos x plus 1.064 equals 7. So divide by the root 106. And now do my inverse cos of 7 over root 106. As if it just says x, really. So again, make sure my calculator's in radians. Shift cos 7 over root 106 is 0.823. Cast diagram to get another answer before I take off the 1.064. So cos was positive. So I do 2 pi minus the answer. So I can do 2 pi minus 0.823. 2 pi minus 0.823 is 5.460. So two answers to start with, but they're not my answers. It's got x plus 1.064. So I say x plus 1.064 equals 0.823. X plus 1.064 equals 5.460. Solving that, x would be, not doing the sums in my head, 0.823 plus, minus 1.064 is 0.241, but we are minus. Now the answers are between 0 and 2 pi. So if you ever get outside that range, you just add multiples of 2 pi. So I'm just going to add 2 pi because I'm outside the range. And that'll get me inside the range of 6.042. By adding 2 pi, I get 6.042 for the first one. Doing the same for the next one, we've got 5.460 minus 1.064. That's 4.396. Now that is within the range. Pi is about 3.14, 2 pi is 6.28, 4.396 is nice in there. And I've not got multiple angles here like 2x or 3x, so I know I'm going to be done. So that's it. I've done my answers all right. I'm out nice and neat. X equals 4.396 and 6.042. And we're done there. SQA Higher Maths 2025, paper 2, question 12. Solve 3 sine 2x plus 4 cos x equals 0. So 3 sine 2x, that's just 2 sine x cos x from the start of the exam paper, plus 4 cos x equals 0, and it's just between 0 and 360. So 6 sine x cos x plus 4 cos x equals 0. Common factor then, 2 cos x, 2 times 3 sine x, and then 2 2s is 4, equals 0. So we get 2 cos x equals 0 and 3 sine x plus 2 equals 0. So that gives me cos x equals 0 on this side and sine x equals negative 2/3. And we're working in degrees here. So cos x equals 0. If you're not sure, by the way, you have got a calculator. Inverse cos of 0 is 90. So we get x equals 90 here, and then it happens again at 270. So there's our first two answers. And then for this one, I'll do the inverse sine of 2/3, never in the negative. Shift sine 2 over 3 is 41.8. Cast diagram. Sine was negative, so we want to pick T and C. So our x for the sine one is 180 plus 41.8 and 360 minus 41.8. Two answers, and you can use a calculator to work them out. So let's just do that. 180 plus 41.8 is 221.8, and 360 minus 41.8 is 318.2. So there's our two answers, and we're done there. We've got all four answers. You can write them out in a line if you want, just to be neat. 90, 270, 221.8, and 318.2 degrees, all degrees. And we're done there. SQA Higher Maths 2024, paper 2, question 12. Solve the equation, which is a trig equation, sine 2x, 2 sine 2x minus sine squared x equals 0. Let's expand that. So let's expand that. It's 2 times 2 sine x cos x minus sine squared x equals 0. So that's 4 sine x cos x minus sine squared x equals 0. That's a little bit tricky, that, because if you take sine x out as a common factor, you're going to get sine and cos in one of the brackets, and that's going to look really funky. So some of you might have been tempted to go sine squared plus cos squared equals 1. Maybe not get anywhere with that, but there are other trig identities you could have used, and one of them is sine divided by cos is tan. So if I divide by cos, you're going to, in a minute, once I take a common factor out, you'll see what's going to happen. So that's the route I'm going to take. I'm going to take common factor out of, not 4 of course, just sine x. And I get 4 cos x minus sine x equals 0. So I've got sine x equals 0, easy enough there. And 4 cos x minus sine x equals 0. So I'm going to divide the whole of this by cos x, because if I do that, divide both sides by the same thing, as that's allowed, I'll get rid of the cos x from the first term, and I'll get a tan x in the second term. So not a bit of trick there. So I'm going to divide this side by cos x, and similarly this side by cos x to be fair. So cos x divided by cos x is 1, so that gives me 4. Sine divided by cos is tan, so that gives me tan x. 0 divided by cos x is 0, and therefore tan x equals 4. And now I can solve both my equations. Inverse sine is 0. Well, you should know that. You need a calculator for that, but let's just check. There's your graph there. And we're in radians or not? Nope. So you've got 0, 180, and 360. Now be very careful here. X for this is equal to, the limit is between 0 is less than or equal to x, so 0 counts, but then less than 360. So 360 doesn't count. So it's just 0 and 180 degrees for this one. 360 does not count, it's outside our range. Inverse tan of 4 then. Make sure you're in degrees. 75.96. .96, and then cast diagrams, what a lot of people usually use, so I'll just use that. We're positive, so I can do 180 plus 75.96, which gives me 255.96. So x equals 0 and 180, and x equals 75.96 and 255.96. Or you might prefer 76 and 256, and that would probably be fine as well. Okay, we're done there. So for related functions, SQA Higher Maths 2015, paper 1, question 4. The diagram shows the graph of the function y equals p cos qx plus r. So it's a trig graph. Write down the values of p, q, and r. Okay, so we need to start off with what this function is. The normal cos graph, if you remember, goes between 1 and -1, like so, and it goes up to 2 pi. So the number in front is called the amplitude, then the period of the frequency, and then how far it's moved up or down. So immediately we can see that if we look at the q first, we've got 1 up to pi over 2, which means if I was to keep drawing that, I would have 4 up to 2 pi, because pi over 2 is 90 anyway. So I can immediately write down that q equals 4, because I should have 4 of them up to 2 pi. Okay, to get our amplitude, if we just work out the difference between the maximum and minimum, I've got 4 and -2 is 6. So to get p, I can just do 4 to -2 is 6. Half of that is 3, so I get 3. P is 3. And then for r, well then now I've got p, it's easy. If it was just 3 cos x, it would go up to 3, but it starts at 4, so I've added 1. So r is just equal to 1. And we're done there. We'll write down the values of p, q, and r. Now, what the function is 3 cos 4x plus 1. 2022 Higher Maths, paper 1, question 4. Y equals the square root of x cubed minus 2x to the power minus 1, where x is greater than 0. We have to differentiate this expression, so let's get ahead and do that. So our first step, or our first mark, is to rewrite the square root of x cubed is x to the 3/2. And we've still got minus 2x to the minus 1. If we've written that, we get a mark there for this x to the power 3/2. We now need to differentiate our terms. So our first mark is for differentiating our first term, which is 3 over 2x. Take away 1 from 3/2, and that's 1/2. There's a mark there. And then differentiating our second term, minus times a minus is a plus, so it's plus 2x to the power of minus 2, taking away 1. So our final mark is 1 here and 1 for this term here. We do not have to go any further than that in this question. So if you did go further, that's fine, but you don't have to. Okay, differentiating a trig function. SQA Higher Maths 2018, paper 1, question 3. h of x is 3 cos 2x, find h dash pi over 6. So if h of x is 3 cos 2x, then h, straight away you can just do h dash x is equal to minus sine 2x, well, minus 3 sine 2x, but then we need to times by 2 because we need to differentiate the 2x part as well. So that's minus 6 sine 2x. This is a paper 1 question, so it's an exact value question. So h dash pi over 6 is equal to minus 6 times sine 2 pi over 6. Subbing it in. That equals minus 6 times the sine of pi over 3. Or if you prefer to work in exact values in degrees, that would be 60. So that equals minus 6, the sine of 60, root 3 over 2. 6 divided by 2 is 3, so it's minus 3 root 3. And we're done there. SQA Higher Maths 2024, paper 1, question 3. Y is 5x squared plus 3 to the 7, find the y by dx. So this is the chain rule. So dy by dx equals, I'll take the 7 down, leave the function alone, 5x squared plus 3, and take 1 away for power, that's 6. And then I need to times by the bracket differentiated. So 5x squared becomes 10x. 3 is nothing. So then that just equals 7 times 10 is 70x. 5x squared plus 3 to the power of 6. And we're done there. Increasing and decreasing functions, SQA Higher Maths 2018, paper 2, question 3. A function is defined a set of real numbers given by f of x is x cubed minus 7x minus 6. Determine whether f is increasing or decreasing when x equals to 2. So we need to work out the gradient of the tangent at x equals to 2. So f dash x is equal to 3x squared minus 7. At x equal to 2, f dash of 2 in other words, we get 3 times 2 squared minus 7. That's 3 times 4 is 12, take away 7 equals 5. And then we need to write a little statement. Since f dash of 2 is greater than 0, the function is increasing at x equal to 2. And we're done there. SQA Higher Maths 2025, paper 1, question 1. A curve has equation y equals x cubed minus 2x squared plus 5. Find the equation of the tangent to this curve out at point equals x equals 2. Equation of the tangent means I need to differentiate. So I do the y by dx, and that tells me the gradient. 3x squared, 2 2's is 4, so 4x, and the 5 disappears, and I want to do that at x equal 2. So at x equal 2, the y by dx is 3 times 2 squared minus 4 times 2. 3 times 2 squared is 4, so that's 12. 4 2's is 8, so I get 4. And that's my gradient. Now I need a point. I've got x equals 2, but I need to find the y. So at x equal 2, we've got y equals 2 cubed minus 2 times 2 squared plus 5. That's 8. 2 2's is 4 times 2 is also 8. Plus 5, which is just 5. So I've now got my gradient, 4, and my point, which is 2, 5. So I can sub into y minus b is mx minus a. Y minus 5 equals 4x minus 2. Y minus 5, 4x minus 8. So y equals 4x minus 8 add 5 is minus 3. And we're done there. SQA Higher Maths 2023, paper 1, question 8. A function is defined as a set of real numbers by x cubed plus 3x squared minus 9x plus 5. Find the coordinates of the stationary points of f and determine their nature. Stationary points means derivative equal to 0. So we can write stationary points occur when f dash x equals 0. So f dash x is equal to 3x squared. 2 times 3 is 6, so 6x minus 9, and then the 5 disappears. So we're saying 3x squared plus 6x minus 9 equals 0. 3 is a common factor, so we get x squared plus 2x minus 3 equals 0. It's keeping our common factor, a standard one to factorise. We've got x and x. It has to be 3 and 1. And plus 3 minus 1 is 2. So that implies x minus 1 is 0, so x equals 1. Or x plus 3 is 0, so x equals minus 3. So we've now got our x part of the coordinate. We might as well try and find our y part. So when x equals 1, y equals, substitute into the original, x cubed plus 3x squared minus 9x plus 5. 1 cubed plus 3 times 1 squared minus 9 times 1 plus 5. So that gives me y equals 1 plus 3 minus 9 plus 5. Y equals 1 plus 3 is 4. 4 plus 5 is 9. Minus 9 is 0. So our first coordinate is 1, 0. When x equals minus 3, we can do the same thing. So y would be minus 3 cubed plus 3 times minus 3 squared minus 9 times minus 3 plus 5. So keeping your wits about, because it is an on calculator, 3 cubed is 27, so you get minus 27. 3 squared is 9 times 3 is plus 27. 9 times 3 is 27, but it's plus because of a minus times a minus. And then you've got plus 5. Minus 27 plus 27 is obviously 0. So then you've got 27 plus 5, 32. So your second stationary point is minus 3, 32. So there's my two stationary points. Now we need to determine our nature by using a nature table. So a nature table is like this. We're going to go along to our first point. This is our x, so minus 3. And then along. And then we're going to examine the other stationary point. So I'm going to go along to 1. And then along. I always keep it separate in case there's a point of a discontinuous point. I don't want to lose marks for it in this case, but just in case. So then we're just looking at our derivative, f dash x. So picking numbers, we know that at minus 3 it's 0, and at 1 it is 0. So we need a number less than minus 3. Now, it's always best just with a derivative to examine it already factorised. So just pick a number less than minus 3. Let's just pick minus 4. Minus 4 minus 1 is negative. Minus 4 plus 3 is negative. A negative times a negative is a positive. So I know it's positive before minus 3. So I can just write that. And after minus 3 but before 1, let's just put 0 in. That gives you negative. And that gives you positive. Negative times a positive is a negative. So we know that it's negative here. And therefore, after minus 3 but before 1, it's still negative. After 1 though, just pick 2. 2 minus 1 is positive. 2 plus 3 is positive. Positive times a positive is a positive. So we get a positive again. So our shape, it goes up, along and down. So max, down, along and up. So it's a min. So we need to state that. So minus 332 is a maximum turning point. And 1, 0 was it? 1, 0 is a minimum turning point. And we're done there. Okay, stationary points under nature, SQA Higher Maths 2017, paper 2, question 7. Find the x-coordinate of the stationary point on the curve with equation y equals 6x minus 2 root x cubed. Then find the greatest and least values of y in interval 1 is less than or equal to x and less than or equal to 9. So part A, stationary points occur when the y by the x is 0. So we need to get ready to differentiate. So with part A, I've got y equals 6x minus 2. I've got x cubed, so the cubed comes along for a ride, but it's a square root, so it's over 2. The y by dx then, 6 minus 2 times 3 over 2, x to the half, because I take away 1 from the power, and then we can say that stationary points occur when the y by dx equals 0. So making this equal to 0, we get 6. These 2's cancel, so minus 3. X to the half equals 0. So 3x to the half equals 6. X to the half equals 2. Remember, x to the half means the square root of x equals 2. So I'm looking for, if I square both sides, I get x equals 4. And we're done there. Part B, hence determine the greatest and least values of y. So at x equal to 1, y equals 6 times 1 minus 2 times the square root of 1 cubed. 6 times 1, 6, minus 2 equals 4. At x equal to 9, the other one, y equals 6 times 9 minus 2 times the square root of 9 cubed. 6 times 9 is 54, minus the square root of 9 is 3, so 2 times 3 cubed. 54, 3 3s are 9 times 3 is 27, 27 times 2 is 54, that gives me a big 0 is the answer at the limits. So now I need to evaluate it at x equal to 4. So at x equal to 4, we've got y equals 6 times 4 minus 2 times the square root of 4 cubed. 24 minus 2 times the square root of 4 is 2, so 2 cubed. 24, 2 cubed is 8 times 2 is 16. 24 minus 16 is 8. So then we can just state our greatest and least values. The greatest value is 8 and the least value is clearly 0. So greatest value equals 8, least value equals 0. And we're done there. The derived function, SQA Higher Maths 2019, paper 2, question 5. The diagram below shows the graph of a cubic with stationary points at minus 2 and 4 as shown on the diagram of your answer book. Sketch the graph of g-x, the derivative. Okay, so let's just draw a picture here. Y and x. Now, we should first of all look at this. It's telling us it's a cubic. A cubic differentiates to a quadratic. So we're expecting a quadratic either going down the way or up the way. And we really just need to identify the roots. Well, the roots happen when the turning points, because the derivative equals 0. So it's just, I need to know that stationary points occur when the y by the x is 0, which means that these are my roots. So I get a root at minus 2 and a root up at 4. So that means that if we examine before minus 2, it's going up the way, it's then dropping down the way, and the derivative will be going back up the way. So it's above the x-axis before minus 2, it's below, in between the roots, and it's above again after 4. So that's how I like to think of this. So I know I'm starting high, I'm dropping below between the numbers, and then I'm going high again, so my curve must come down like so. Obviously, I can't quite get the turning point. I know the turning point happens at 1 in the middle of the roots, but I don't know exactly what it would be on the y-axis, so I don't need to work that out. And there we are. There's my graph of the day. SQA Higher Maths 2025, paper 2, question 10. A hotel owner is designed and shown signs shown with room numbers. There's the sign. Each sign is a rectangle, right angle above it. The length and breadth is 5x and y. We've got 5x and y, and the shorter sides of a triangle are 3x plus 4x. And obviously it's a right angle. It shows that the perimeter is given by that. So let's have a look and work on this. It also tells us that the area of the sign is 150. So let's start off, we have something for our perimeter. Our perimeter is all the way around, so I need to go y plus 5x plus y plus 5x plus y plus, well, just 3x and 4x. So that equals 5, 6, 7, 8, 9, 10, 11, 12x plus 2y's. So I need to get rid of that y somehow. It says the area of the sign is 150. So area is 150. Well, what is the area? It's base times length, or base times height, 5xy, plus, now this is a right angle triangle, so it's just half the base times the height to get the area of that. Half the base would be 2x times 3x. I'll write that out, half the base times the height, so that's 5xy plus a half of 4 is 2 times 3 is 6, and x times x is x squared. But that equals, remember, 150. And my perimeter in the question doesn't have a y, so I'll make y the subject. So 5xy equals 150 minus 6x squared. So making y the subject, y is 150 minus 6x squared over 5x. So we can write our perimeter as 12x plus 2y is 12x plus 2 times 150 minus 6x squared over 5x. So what's that? 12x, 150 divided by 5 is 30, times 2 is 60, but then there's an x on the bottom. So then another one, 2 6's is 12, so that's minus 12 over 5, but then the x will be an x squared over x, so that's just x on the top. So working that bit out, 12x minus 12x over 5 plus 60 over x. Now it had a decimal answer, so I'll just work it as a decimal. 12 minus 12 over 5. That's 9.6. So our perimeter is 9.6x plus 60 over x as required. But if you couldn't do that, you should have just moved on and skipped it, because you can do part B. Each sign will be using a lightning strip placed around its perimeter. The hotel owner requires the perimeter of the sign to be as small as possible. Find the minimum value of P. Optimization, differentiation. So part B, minimize this then. So stationary points occur when P dash equals 0. So P dash, well, I'm going to have to get ready to differentiate first actually. So P equals 9.6x plus 60x to the minus 1. So P dash is going to be 9.6 minus 60x to the minus 2, and that's going to equal 0. So there's a few ways to solve this, but what I usually like to do is just say that that's minus 60 over x squared. And then just times both sides by x squared. So that gives me 9.6x squared here, minus 60x squared over x squared, so it's gone, equals 0x squared. And then I can solve that. 9.6x squared equals 60. So x squared is 60 over 9.6. So x is the square root of 60 over 9.6. And I'm pretty sure the question told you that x would be greater than 0. It has to be anyway. Does it say anything about it? It doesn't, but once we square root that, we can't have a negative x because you can't have a negative length. So that will just be a positive. Which is 2.5, because x cannot be minus 2.5. Okay, so it is 2.5, and then we have to minimize the perimeter, so we actually have to sub that back in. But before we do that, we need to do a nature table to check that it's a minimum. Along to 2.5 and along, P dash, just pick 2 and 3, say. So subbing in 2, we get 9.6 minus 60 over 2 2's is 4. Well, that's a negative number. That's 0. And when we sub in 3, you get 9.6 minus 60 over 3 3's is 9, which is a positive number. So that goes down, along and up, and therefore x equals 2.5 as a minimum TP. So x equals 2.5 minimizes the perimeter. What a perimeter was? A perimeter was 9.6x plus 60 over x. 9.6x plus 60 over x. So that's 9.6 times 2.5 plus 60 over 2.5. 9.6 times 2.5 plus 60 over 2.5 is 48. So our minimized perimeter is 48. And I'm pretty sure our units were centimetres or metres. Let's have a look. Centimetres, I think. And we're done there. SQA Higher Maths 2025, Paper 1, Question 4. 3 log base 3 2 plus log base 3 1 over 24. Rules of logs, log base 3 2, and then the 3 can come up as a power. Plus means times, so that's times 1/24 to get it as 1 log. So that's it as 1 log. Simplify that, that's 8 times a 24th. That's a third when you simplify the fraction. So what does that tell us? Well, 3 to the power of something is a third. 3 to the power of minus 1 is the same as a third because it's 1 over 3 to the 1. And therefore the answer to that question is minus 1. 3 to the power of minus 1 is a third. And we're done there. SQA Higher Maths 2023, Paper 1, Question 3. Solve log 5x plus minus log 5(3) equals 2. So rules of logs, if it's a minus with the same base, you can divide these together. So in one step, we get log base 5 of x over 3 equals 2. And then you need to get rid of the log. So remember, it's base to the power of this equals this. So in other words, 5 squared equals x over 3. Or, to write it nicely, x over 3 equals 25, 5 squared. X divided by 3 equals 25, so that means that x must be 3 times 25. So x equals 75, and we're done there. SQA Higher Maths 2025, Paper 2, Question 13. A radioactive substance has been collected, decays over time, and the mass is given by m equals 150 e to the minus 0.0054 t, where m is the mass and t is the years after the radioactive substance is collected. Find the initial mass of the substance. Initial means t equals 0, so m equals 150 e to the minus 0.0054 times 0. That's 150 e to the 0. Well, e to the 0 is just 1, so that's 150. It says it's in micrograms, I think. Yeah, so I'll just write micrograms to be on the safe side. And we're done there. Part B says, calculate the time taken for the mass of the substance to decay to 120. So m is 120. So I'll just write 120 equals 150 e to the minus 0.0054 t. That becomes a fraction. That stays there, e there. I will simplify the fraction. So that's 12 over 15. And 3 goes into 12 4 times, and 3 goes into 15 5 times. Take the log of both sides now, because I've got my t in the power position. So ln 4/5 equals ln e to the minus 0.0054 t. That means I can take my 0.0054 t to the front. So ln 4/5 equals minus 0.0054 t ln e. But ln e, remember, log e is 1. So that means I can work out my t is just ln of 4/5 all divided by minus 0.0054. Get your calculator. ln bracket, I've already got a bracket, 4 over 5 equals that. I'll press then divide minus 0.0054, 41.32 roughly. and it was in years. And we're done there. SQA Higher Maths 2023, paper 1, question 9. The diagram shows the graph of function f of x is log base 3x. X is greater than 0, of course. The inverse function does exist. In the diagram in your answer book, draw the graph of the inverse function minus 1. Well, let's examine the inverse function first. The inverse function of a log is an exponential. And essentially, the easiest way to draw it, imagine a dotted line here, y equals x. The coordinates just switch places, okay? So here is my normal y equals x. So 1, 0 becomes 0, 1. And 3, 1 becomes 1, 3. And it just gives you an exponential curve. And that would be 1, 3. So that's the inverse function of x. So now I just need to take away 1, which means just to move it down by 1. So 1 is going to go to 0. And 1, 3 is going to go to 1, 2. So I can just draw it now. There's 0. It's obviously going to drop below because that's where your asymptote is, essentially. So it's going to go along, up through 0, and start climbing. And we just put that point on that we noted, which was 1, 3. So it now becomes still 1, but 2. And we're done there. SQA Higher Maths 2024, paper 2, question 6. Two variables x and y are connected by the equation y equals axb. The graph of log 5y and log 5x are shown, and it's a straight line. So we've got log 5y by log 5x, and find a and b. Right, so I always usually start with the equation. Some people skip ahead, but I don't like to. So I'll start with that, and I log both sides. The base is 5. Log base 5 y equals log base 5 ax to the b. So now I can separate my log out on the right-hand side to log base 5a plus log base 5x to the b. So that means log base 5y equals log base 5a plus b comes out the front, log base 5x. And put that in a kind of form of y equals mx plus c. You've got your log base 5y. I'll take the x bit first. So b times log base 5x plus log base 5a. So now just comparing your graph, your y-axis is log base 5y, so that's like your y, and your x-axis is log base 5x, so that's like your x. So that bit there is your gradient, mx, and that bit there is your c. So the gradient is b. So what's the gradient of this line? Well, I've got 2 points, 0, minus 2, and 410. So the gradient between 0, minus 2 and 410 is what we're going to do. So my gradient equals 10 minus minus 2, 4 minus 0, that's 12 over 4, that's 3. So that means that to answer the question, b equals 3. Now it says find c. Well, I already know where it cuts the y-axis, 0, minus 2. So that's it, c is minus 2. So if c is minus 2, that means that log 5a equals minus 2. So that means that 5 to the power of minus 2 equals a. That's 1 over 5 squared. 5 squared is 25, so a is 1/25. And we've got that, so we're done. SQA Higher Maths 2025, paper 1, question 7. Show that x plus 3 is a factor of this, and then hence otherwise solve. So you can sub in directly, or as most of you will do, you'll use this synthetic division. So you've got 5, 16, minus 1, minus 12, x plus 3, so I sub in minus 3. 5 minus 15. 16 minus 15 is 1. 1 times minus 3 is minus 3. Minus 3 minus 1 is minus 4. Minus 3 times minus 4 is 12. And we'll get 0. So since the remainder equals 0, that implies that x plus 3 is a factor. Well, the way you could say that is f of minus 3 is 0, so x plus 3 is a factor. Now we have to solve it, and it's the same equation. So for part B, we've already got x plus 3 as a factor, so I'll just write that again. And then we've got 5, 1 minus 4, 5x squared plus x minus 4 equals 0. So a little bit of hard factorising if it does factorise. Now if you're not sure if it factorises, check the discriminant. 1 squared is 1, 4 5s is 20. 20 times 4 is 60. And that's positive, isn't it? 4 5s is 20. If you're not sure if factorise, check the discriminant. If a discriminant is a square number, it's factorisable. So 1 squared is 1. 4 5s is 20. 20 times 4 is 80. That's a minus minus. That gives you 81 for the discriminant. So that means it's definitely factorisable because 9 9s is 81. So a little quick check there. And if you've got a negative number for your discriminant, you know you've got all the solutions. So it must be 5x and x. I was going to write 5x twice there. And it can't be 5 times 4 is 20. That makes no sense because I'll never get back down to 1. So it must be 5 times 1, which is 5. The outside is 5. And then the inside must be 4, taking away 4. Take away 4 plus 1. So that means that x is equal to minus 3. 5x minus 4 is 0. 5x is 4. So x is 4/5. And finally, the other one, x equals minus 1. And we're done there. SQA Higher Maths 2016, Paper 1, Question 15. Identify a polynomial from its roots. So the diagram below shows the graph of f of x, which is k, x minus a, x minus b squared. Find the values of a, b, and k. There's one of my roots there. And there's the other root there. That's a repeated root. And I know that because it's a turning point and a root. So that one is my b, and the other one is my a. So I can immediately say for part A, f of x equals k times x minus 4, x plus 5 squared. And then we can use the point 1, 9 to work out our k. X equals 1, y equals 9. So we get 9 equals 1, k times 1 minus 4, 1 plus 5 all squared. So 9 equals k times minus 3. 1 plus 5 is 6. 6 6 is 36. So 9 equals minus 108k. So k is 9 over minus 108 minus 12. So we've got k as minus a 12. We've got a equals 4 and b was equal to minus 5, remember, from our roots, 4 and minus 5. So we're done there. Part B says, for the function g of x equals f of x minus d, where d is positive, determine the range of values for d so that g of x has exactly one real root. Okay, let's have a look at this. If it's got one real root, it only crosses the x-axis at one point. So this is going to move down, so that makes it go, but it's still going up. So this turning point has to go underneath here. So that the only place it crosses is when it first initially drops down. Then it goes up, and it's going to turn before it hits there and go back down. Well, that length is 9, so d must be greater than 9, and it's as simple as that. So it's just really working that out by looking. So for part B, I just write d is greater than 9, and we're done there. SQA Higher Maths 2018, Paper 1, Question 7 for the equation of a tangent. You've got this curve shown in the diagram. Write then the coordinates of P, the point where the curve crosses the y-axis. So for part A, cuts the y-axis when x equals 0. So subbing 0 in, that's really easy. 0 minus 0 plus 0 plus 5. When x is 0, y is 5, so it's 0, 5. Part B, determine the equation of a tangent to the curve at P. The equation of a tangent, I can find the gradient by differentiation. So dy by dx is equal to 3x squared minus 6x plus 2. And at the point P already we know is x equal to 0, y equals 5. So when x equals 0, dy by dx equals 3 times 0 squared minus 6 times 0 plus 2. 0 plus 2 equals 2. So our gradient equals 2, and our point P, remember, is equal to 0, 5. So y equals mx plus c is the easiest one to use here. Y equals 2x plus 5. Or you could use y minus b equals mx minus a and still get 2x plus 5. Question C, find the coordinates of Q, the point where the tangent meets the curve again. So you're just going to solve simultaneous equations here. x cubed minus 3x squared plus 2x plus 5 was our curve. It's equaling 2x plus 5 at points of intersection. So we can solve that quite easily. If these cancel each other out, if we take it over, minus 2x minus 5, they disappear. So that just leaves me with x cubed minus 3x squared equals 0. Common factor of x squared, so you get x minus 3. So that means that x squared equals 0, so x equals 0, or x minus 3 is 0, so x equals 3. Well, we already know 0 is one of our points, so the second point of intersection is that x equals 3. So when x equals 3, y equals 2x plus 5. So that is 2 times 3 is 6 plus 5, which is 11. The second point is 3, 11, and we're done there. SQA Higher Maths 2025, Paper 2, Question 2. Express 2x squared plus 16x plus 5 in px plus q squared plus r form, completing the square. So how this works is, you take 2 as a common factor of the first terms, x squared plus 16x, so that becomes 8x. Then you've got plus 5 hanging out, and you complete the square in the x squared plus 8x. So that's x plus 4 all squared. Remember to take away 4 squared. But that's stuck inside this bracket, and the 5 is hanging out on the outside. So that's 2x plus 4 squared. And I'll have to do 2 16ths, which is 32, plus 5. So finally I get 2x plus 4 all squared. Minus 32 plus 5 is minus 27. And we're done there. SQA Higher Maths 2025, Paper 1, Question 11. The equation 9x squared plus 3kx plus k is 0 has 2 real and distinct roots. Find the values, or range of values for k. So if we've got 2 real and distinct roots, the discriminant must be strictly greater than 0. Not even greater than or equal to, because if it's equal to 0, it's got 2 real and equal roots, and it's got 2 real and distinct. So what is our b? 9k, 3k squared minus 4 times 9 times k is greater than 0. That's 9k squared minus 36k is greater than 0. So to solve something like this, you look at the roots. It's just a quadratic inequality. And that gives me 9k squared minus 36k equals 0. 9k is a common factor to give k minus 4. So k is 0 from the first place, and k is 4. So that answers what the roots are, so I draw it. So we've got 0 and 4. It was a positive k squared. So it looks something like that, where that's 4 and that's 0. And it says we want to be greater than 0, so above the x-axis. Well, above the x-axis, I'm continuing that way, and I'm continuing that way. So our final answer is k must be less than 0, or k must be greater than 4 for the range of values. And we're done there. Okay, the discriminant, SQA Higher Maths 2018, Paper 2, Question 10. The equation m squared plus m minus 3x plus m equals 0 has 2 real and distinct roots. Determine the values, the range of values for m. So 2 real distinct roots. That implies that b squared minus 4ac must be greater than 0. So in this case, our a is a number in front of x squared, which is 1. Our b is a number in front of x, which is m minus 3. And our c is what's left at the end, which is just m. So being careful, subbing this in, we get m minus 3 all squared minus 4 times 1 times m is greater than 0. So we need to then expand our brackets. So that is m squared minus 6m plus 9. And then 4 times 1 is 4 times m. So minus 4m is greater than 0. So that gives me m squared minus 10m plus 9 is greater than 0. So we need to examine the roots. So looking at the roots, we can try and factorize this. We've got double brackets, m and m, 9 and 1, minus 9 minus 1 gives you minus 10. So the roots have m equal to 1 and m equal to 9. And now we need to draw a graph to examine when is the inequality greater than 0. So that's why we look at the roots. So we'll draw a quick graph. We put our roots on at 1 and 9. We know that the shape goes down the way because it's a positive m squared, so we can just draw a quick sketch of a graph. It doesn't have to be anything too fancy. And we're looking at when it's greater than 0, so I'm looking at when it's above the x-axis. So using a different colour pen, it's above the x-axis over here, and it's above the x-axis over here. In other words, when m is less than 1, or when m is greater than 9. And that's our final answer. SQA Higher Maths, Paper 1, Question 3. Circle C1 has this equation, and C2 has centre 4 minus 2. The radius of C2 is equal to the radius of C1. Find the equation of circle C2. So we have got our equation up here, and just remember, from our equation, x squared plus y squared minus 2x minus 2y minus 26 equals 0. You're given at the start of the exam paper the radius. The radius is quoted as equaling the square root of g squared plus f squared minus c. And your g and your f, well, this is called 2g and 2f. So 2g is minus 6 and 2f is minus 2. So my g is minus 3 and my f is minus 1. So my radius is equal to minus 3 squared plus minus 1 squared. Take away c, but it's a minus already, so plus 26. So that means that going down here, my radius is equal to the square root of 9 plus 1 plus 26. That's the square root of 36, which is equal to 6. So we've got our radius, and we know the circle centre is 4 minus 2. So we know the equation of C2 must equal x minus 4 squared plus y plus 2 squared equals 36. And we're done there. SQA Higher Maths 2024, Paper 1, Question 7. The line y equals 2x is a tangent to the circle x squared plus y squared minus 14x minus 8y plus 45. Find the coordinates of the point of contact. Well, finding the point of intersection means solving simultaneous equations, so I'm just going to sub it in. So I've got x squared plus y squared, which is 2x, minus 14x, minus 8y, so it's 8 times 2x, plus 45 equals 0. And we'll just solve that for x. So that's x squared plus 4x squared minus 14x minus 16x plus 45. That's 5x squared, and that's minus 30x, and that's 45. So 5 is a common factor, x squared minus 6x plus 9. Remember, this is a tangent, so if you get more than one answer, you've made a mistake here. So watch out. You could just complete the square, but I can see here that I can just factorise it. Half the term, that's 3 and 3, minus minus. Minus is a minus is a plus, that's plus 9. Minus 3 is minus 6. So you get x equals 3 as your x coordinate, and therefore y equals 2 times 3, 2x, which is 6. So your point of contact is 3, 6, and we're done there. SQA Higher Maths 2025, Paper 1, Question 9. Find the coordinates of the point of intersection of the line with the equation x plus 1 and the circle x squared plus y squared minus 2x plus 6y minus 15 equals 0. So we sub in x plus 1. So we've got x squared plus x plus 1 all squared minus 2x plus 6 times x plus 1 minus 15 equals 0. That gives me x squared plus, square out that bracket, x squared plus 2x plus 1, you can use double brackets for that, minus 2x plus 6x plus 6 minus 15 equals 0. So how many x squares have I got? I've got 2 of them. For x's, I've got 2 minus 2 is 0 plus 6. And for numbers, I've got 1 plus 6 is 7 minus 15, which is minus 8. So we can see that 2 is a common factor. X squared plus 3x minus 4. And hopefully that factorises to give us x and x, 4 and 1. And it's going to be plus 4 minus 1 to get plus 3 in the middle. So x equals 1 or x equals minus 4. Find the coordinates of the points of intersection. Well, I've got my x's, I need my y. Y was x plus 1, so when x equals 1, y equals 1 plus 1 is 2, so that's 1, 2. And when x equals minus 4, y equals minus 4, add 1, which is minus 3. So we get minus 4 minus 3, and we're done there. SQA Higher Maths 2025, Paper 2, Question 14. This was a doozy, this one. I think a lot of people found this hard, so let's get into it. Circle C1 has equation x plus 5 squared plus y minus 6 squared equals 9. Find the centre and the radius. Okay, so the centre is easy enough of C1. That's just x plus 5, so minus 5, y minus 6, so plus 6. And then the radius is the square root of 9, which is 3. So nothing major there. C2, that's radius as well. So minus g minus f. So 2g is 14, well, minus. So g is minus 7. 2f is 6, so f is 3. So it's minus g minus f, 7 minus 3. The radius is the square root of 7 squared plus minus 3 squared minus the 54 in the end. This is just all from the start of the exam paper, of course. 7 sevens is 49, 3 threes is 9. 7 sevens is 49 and 3 threes is 9. Minus 54 is 4, so the radius of that one is 2. So R2 is 2. We'll call that R1. And we're done there. We'll get to part C now. C says, circles C1, C2, C3 are touching as shown in the diagram. The centre of C3 lies on the line joining the centre of C1 and C2. Determine the equation of C3. And I think this is where a lot of us will go, what do I do with this? This is the last question of the paper. It is designed to be difficult, okay? So don't worry too much. But let's see what we already know. R1 was 3, remember, and R2 is 2, and C1 was minus 5, 6, and C2 was 7 minus 3. So we've got all that information to start with. So let's just shove some stuff on here. I need the centre and I need the radius of this, okay? So the first thing I'm going to do is try and work out the radius by looking at the distance between C1 and C2, because I've got two centres. So the distance of C1 to C2, distance formula of Pythagoras, you've got 7 and minus 5, the difference between them is 12. And then you've got 6 and minus 3, the difference between them is 9. 7 minus 5 is 12, minus 3 minus 6 is 9. 12 squared plus 9 squared is 225, which square roots to 15. You check out yourself, I just know that one. So we know that the radius, the distance between centres is 15. So how does that help me get the radius, you might be wondering? So I've worked out my distance between the centres, so I now know that this whole line here is 15. So how am I going to get my radius? Well, I know nothing about this bit. But what I can do is I can say, well, look, what if I tried to go for the diameter? If I went all the way along here, I would have the distance plus an extra 3, but then I would be that many too far, so I'd have to take away 2. So it's the whole distance between the centres plus the 3 take away the 2. So the diameter is 3 plus 15 take away 2, which is 15, 16, 17, 18, minus 2 is 16. So the radius C3 is half of that, which is 8. So I've got one bit of the information now. This whole line, we know that now that this bit's 8, and then we've got 2 extra, so that's 10. And what about the other side of that line? Well, we've got 3 to this point, and we know that the radius of this thing here is, well, the distance between centres is 15, so that must be 5. So it must be 5 and 10. So I'm going to draw that out on a straight line for you. If I just draw it as like this, and that's C1 there, C3 somewhere, and C5, since we know the whole whole line is 15. And since we know the distance between here and here is 10, then we know the distance between here and here must be 5, because the distance between the centres is 15. So now that we've got that, we can just use vectors to work out our centre. Now you can use the section formula, but I don't like the section formula. So I'm just going to use vectors. C1 was minus 5, 6. And C2, was 7 minus 3. And I want to work out this one. So let's call that x, y, z for the sake of it. Then I know that if that's 5 to 10 as a ratio, I can simplify that to 1 to 2. So far, so good. So x to y over y to z equals 1 to 2, 1 over 2. That's what I'm thinking about. So that means that y to z equals 2xy. So y to z is z minus y equals 2y minus x. And I'm trying to get y because that's what I've called a middle point or vector. So z minus y equals 2y minus 2x. So if I take the y over here, I get 3y, and I get z plus 2x. So finally, y is z plus 2x over 3, or a third of z plus 2x. Well, we've got z and x. Z is 7 minus 3, plus 2 of x. X is minus 5, 6, so that's minus 10, 12. That's a third. 7 minus 10 is minus 3. Minus 3 plus 12 is 9. A third of that is minus 1, 3. So that means that our point centre, C3 we're calling it, is minus 1, 3. And we know its radius now already, way back up here. I think we worked out that it was 8. So we need to know the equation then. X minus minus 1 plus 1 squared plus y minus 3 squared equals 64. And finally, we're done there. Okay, unusual circle questions. SQA Higher Maths 2019 paper 1 question 16 had this one. P is the point with coordinates 4k and C is the centre of the circle with this equation. Show the distance between P and C is given by square root of k squared plus 4k plus 13. So part A, we've got our points 4 and k, and the centre of our circle is equal to, well, let's have a look. We've got 1 minus 2. So we can work out the distance between them. That is going to be the square root of the difference in the x's, 4 minus 1 squared, plus the difference in the y's, k minus minus 2 squared. Tidying that up, we get the square root of 3 squared plus k plus 2 squared. That equals the square root of 9 plus k squared plus 4k plus 4, which equals the square root of k squared plus 4k plus 13 as required. Part B says, hence otherwise find the range of values of k such that p lies outside the circle. So let's draw a little picture for this. We've got a circle, and the centre of that circle is 1 minus 2. And we can look to see what the radius is. We know the radius is 5, the square root of 25. So that distance is 5, that's our radius. So if P is outside the circle, then clearly the distance between the centre and P must be bigger than 5. It has to be over 5. So we can then just say that the square root of k squared plus 4k plus 13 is greater than 5. And we can go from there. That's because our radius, remember, is 5. So, quadratic inequality, square both sides, k squared plus 4k plus 13 is greater than 25. Taking the 25 over, we get k squared plus 4k minus 12 is greater than 0. And this is a quadratic inequality, so we examine the roots. So looking at our roots, we've got k squared plus 4k minus 12 is equal to 0. Double brackets, we get k and k, 6 and 2, plus 6 minus 2 is 4. So our roots happen at k equal to 2, or k equals minus 6. Drawing a quick sketch then of that graph, we get 2's over here somewhere, minus 6 over here. It's a positive k squared, so it is a happy face. We don't need the turning point or anything because we're just looking to see when is this bigger than 0. Well, it's bigger than 0 above the x-axis, so it's over this side, it's always bigger than 0, and over this side, it's always bigger than 0 as well. So our final answer is k is less than minus 6, or k is bigger than 2. And we're done there. SQA Higher Maths 2025, Paper 1, Question 3. Integrate 12 over x squared plus x to the half dx. So I need to get it ready to integrate. So that's 12x to the minus 2 plus x to the half dx. Add 1 to the power, divide by the new power. Minus 2 add 1 is minus 1. Divide by minus 1 gives me minus 12. Add 1, so that's 3 halves. And when you divide by 3 halves, it's the same as doing 2 thirds. And then you've got plus c. And really, that's it. But I'll probably make it look neater, just for the sake of it. It doesn't tell you to really do anything with positive powers or anything. Minus 12 over x, plus 2 thirds x to the 3 halves, plus c. You could do as much as you want with that, or as little as you want with that. You could do, if you really wanted to, minus 12 over x, plus 2 thirds, and it would be the square root of x cubed plus c, but I don't really see any need to do that. And we're done there. A trig function with the chain rule, SQA Higher Maths 2016, Paper 1, Question 5. Integrate 8 cos 4x, add 1 dx. Cos goes to sine, check the start of exam paper, so that equals 8 sine, the whole function 4x plus 1. But then I need to differentiate 4x plus 1. Well, that's 4, and divide by that. So divided by 4, and don't forget your plus c. 8 divided by 4 is 2, so we get 2 sine 4x plus 1 plus c. And we're done there. SQA Higher Maths 2025, Paper 2, Question 7. Integrate 3x plus 2 to the power of 7. Alright, so this is the chain rule. 3x plus 2 to the power of 7, I add 1 to the power is 8, I divide by the new power, 8. But you also divide by whatever's inside that bracket differentiated. You need to break the chain. 3x plus 2, differentiate it is 3. So there we are there. And then we've got plus c, of course. Don't forget your c. That's 3x plus 2 to the 8. 3x is 24, so I'll just write it as 1 over 24 for neatness, plus c, and we're done there. Equations SQA Higher Maths 2019, Paper 2, Question 13. A function defined a set of real numbers. It is shown that the rate of change of f with respect to x is given by this equation. The graph of y equals f of x crosses the x-axis is 7, 0. Express f of x in terms of x. This question, I suppose, is asking you about do you know what rate of change is? Well, rate of change means differentiation. So we know that f dash x equals 3x squared minus 16x plus 11. So that means that f of x is the integral of this. And we'll get to the second bit of information to get c in a minute. So integrating that, we get x cubed times 3 over 3 minus 16x squared over 2 plus 11x plus c. So there's our initial step. We can simplify that in a moment, but it tells us that the graph of y equals f of x crosses the x-axis at 7, 0. Well, 7 is x and 0 is y. So we can substitute 0 and 7 into our equation. So we've got f of x, tidying it up, equals x cubed, minus 16 over 2 is 8x squared, plus 11x plus c. So when x is 7, y is 0. When x equals 7, y, which equals f of x, equals 0. So subbing that in, we get 0 equals 7 cubed minus 8 times 7 squared plus 11 times 7 plus c. This was a calculator paper, so you could do all the sums in a calculator, but 7 cubed is 343. 7 squared is 49 times 8 is 392. 11 sevens is 77. And then we've got plus c, and 0 equals this. Tidying all that up, we get 0 equals 343 minus 392 plus 77 is 28 plus c, and therefore c must equal negative 28. We've got our c, so we'll just sub it back into the equation we just found above. So therefore f of x is equal to our x cubed minus our 8x squared plus 11x minus 28. And we're done there. 2025, paper 2, question 3. The diagram shows the graph of y equals x squared minus 2x add 3. Calculate the shaded area. Shaded area, the integral between 2 and 4 of the graph then. So it's the integral between 2 and 4 of x squared minus 2x plus 3. dx. Integrate, so add 1 to the power, divide by the new power, minus 2x squared divided by 2 plus 3x between 2 and 4. Simplify, minus x squared plus 3x between 2 and 4, and then sub in. Now, you should just be subbing in, because if you don't show your sub in and then you mess it up, you might lose more marks. So always show your sub in, and then you get a mark at that position, minus a third, 2 cubed minus 2 squared plus 3 times 2. I mean, if you can't work out the rest, you're probably going to lose in 1 mark. So 4 cubed is 64 over 3. 4 squared is 16. 3 fours is 12. Minus 2 cubed is 8 over 3. 2 squared is 4. 3 twos is 6. Now, I usually like to work with that calculator as much as I can, just because I'm used to it. So 64 over 3 minus 16 plus 12 is minus 4. And then I've got minus 8 thirds. Minus 4 plus 6 is 2. And then I can take things out that bracket. 64 over 3 minus 8 thirds. Then I've got minus 4 still, then minus 2. 64 minus 8 is 56. So you get 56 thirds, and minus 4 minus 2 is minus 6. So that's 56 over 3 minus 18 over 3. 56 minus 18, well, that gives you 46, 38. So we get 38 over 3 unit squared. Or you can leave your answer as a mixed number if you really want to. SQA Higher Maths 2025, paper 2, question 8. EABCD is a rectangular base prism with AD is shown, DC and DE. Find B to E in terms of IJK. So B to E, where's B? There it is. So I need to get all the way to E. So I could go along here. That seems reasonable. So B to C, which is the same as A to D. So let me write that down, 6, 4, 2. I always work in component form and change back. And then I need to go along here, which is the opposite direction of D to C. So minus 2, minus 4, and 2. And then I need to go up here to get to E, which is the same direction as D to E. So plus again, minus 4, minus 3, 4. So I'll work out my numbers. 6 minus 2 is 4. Minus 4 again is 0. 4 minus minus 4 is 8. 8 minus 3 is 5. 2 minus 2 is 0, plus 4 is 4. So in IJK form, I've got 0i plus 5j plus 4k, which you can just write as 5j plus 4k. And you're done there. Higher Maths 2025, paper 2, question 5. Show that the points are collinear and then find the ratio that B divides A to C. So for collinearity, I do A to B, which is B minus A. So that is 6 minus minus 3, which is 9. minus 1 minus 2, which is minus 3, and 5 minus minus 1, which is 6. And then we do the same for b to c, which is c minus b. So that is 12 minus 6, which is 6, minus 3 minus minus 1, which is minus 2, and 9 minus 5 is 4. So we get 6, 2, 4, and 9 minus 3 and 6. So 6, 12, 18, 9, 18. The lowest common multiple between, say, 9 and 6 is 18. So if I just times that by 2, that equals that times 3, hopefully. So let's just check. 2ab hopefully equals 3bc. So they're multiples of each other. 9, 2 9s is 18, 2 3s is 6, and 2 6s is 12. 3 6s is 18, 3 2s is 6, 3 4s is 12. So we get the same. And therefore, we can then say that AB and C are parallel, but B is a common point. So AB and ABC are collinear. And now says state the ratio that B divides AC. Well, this is easy now. If you've written it like this, 2AB equals 3BC, then you just want AB over BC, and that's the fraction. Well, AB over BC is just 3 over 2, and that means that our ratio is simply 3 to 2. And we're done there.
SQA Higher Maths 2018 Paper 1 Question 5, Vectors and Collinearity. A, B and C are collinear. State the ratio B divides A to C. So if B divides A to C, we can find A to B and B to C and then compare them. So let's do A to B first. Remember, that's B minus A. So that is 5t5 minus 3, 4, minus 7. So now taking away them, 5 minus 3 is 8. T minus 4. And 5 minus 7 is 12. So we get our A to B. Now let's do the same for B to C. So that's C minus B. So that equals 798 minus 5t5. 7 minus 5 is 2. 9 minus t. Don't worry about them now, that'll be for part B. And 8 minus 5 is 3. And now we still need to compare the elements. The first element, 8 to 2, well, that's 4. Divided by 4, 12 to 3 is 4. So the ratio that B divides A to C, B divides A to C, and the ratio 4 to 1. Part B, state the value of T. Well, we know that 4 times BC equals AB. So for part B, 4 times BC equals AB. So that means that we can say that 4 lots of 9 minus T is equal to T minus 4. 4 9s is 36, minus 4T is T minus 4. 36 plus 4, that gives you 40 on this side, equals 4T plus T is 5T. So T must equal 8. And we're done there.
SQA Higher Maths 2019 Paper 1 Question 9 on vectors and scalar product. Vectors U and V have these components, where P is a member of the real numbers. Find an expression for U dot V for part 1. Well, U dot V is told to you at the start of the exam paper. If you forget, it's either got an angle in it, or it is times each element, then plus the second element, then plus the third element, all times together. So I can just write that down. I've got P times 2P plus 60, plus minus 2 times minus 3, plus 4 times 6. So then we can just simplify that, expand my bracket, I get 2P squared plus 16p plus 2 3s are 6, minus times a minus is a plus, 6 4s is 24, so that's 2p squared plus 16p plus 30 is our simplified u dot v. Part 2. Determine the values for p for which u and v are perpendicular. Well, if u and v are perpendicular, that means that u dot v equals 0. And why is that? Well, if you look at start exam paper, you're given the formula sheet, which says that u dot v is also the size of a times the size of b times the cosine of theta. Now, if theta was 90, cosine 90 is equal to 0, so u dot v is 0 when they're perpendicular. But you could just memorise that. So u dot v equals 0 means I can write 2p squared plus 16p plus 30 equals 0. Take 2 out as a common factor, p squared plus 8p plus 15. So that's a quadratic. So from National 5 Maths, I'm looking for double brackets probably. Two numbers that times together to make 15, but add together to make 8. Well, that's 5 and 3. So it's plus 5 and plus 3. So that means that p plus 3 equals 0 or p plus 5 equals 0. Solving both of the equations, we get p equals minus 3 or p equals minus 5. And we're done there. Part B says, determine the value of p for which u and v are parallel. So if a parallel, that means that I can times this one by something to get this one. So let's just compare the elements. I've got minus 3 over minus 2, that's 3 halves. And similarly, I've got 6 over 4, which is also 3 halves. That means that if I times this one by 3 halves, I get this one. So I can just write that down. 3 halves of p equals 2p plus 16. So for part B, 3 halves of p equals 2p plus 16. So I've got that equation to solve. So if I put brackets around that side, that means I can times by the bottom. So 3p is equal to 2 times 2p plus 16. 3p equals 4p plus 32. So taking it over to the other side, you would get minus p equals 32 or p equals minus 32. And we're done there. SQA Higher Maths 2025, paper 1, question 10. The vectors u and v are such that u is 110, v is 13k. The angle between them is 45. Find the value of k. So a question like this, you're looking at u dot v. And there's two ways to do u dot v. The first way is to times the vector's components together. So the top numbers, 1 times 1, plus the middle numbers, 1 times 3, plus the bottom numbers, 0 times k. So I'm going to start for there. That gives me 1 plus 3 plus nothing, which is 4. So I actually now know that u dot v is 4. But the other formula is u dot v equals the size of u times the size of v times the cos of theta. Well, I know the size of u, size of v, and cos of theta, and I know u dot v is 4, so it's pretty simple now. I don't know the size of u and v, but I can work it out actually. So the size of u is the square root of 1 squared plus 1 squared plus 0 squared. That's root 2. And the size of v is the square root of 1 squared plus 3 squared plus k squared. I can't do much with that, so that's 3 3s is 9 and 1 is 10, 10 plus k squared. So I'll just keep it, it's fine, it's about algebra. So u dot v is uv cos theta root 2 root 10 plus k squared. Cos theta, and theta told us was 45 degrees, and that all equals 4, because I just worked out u dot v was 4. Exact value triangle, 45, 1, 1, root 2. Cos of 45 is 1 over root 2. So that gives us root 2, root 10 plus k squared, 1 over root 2 equals 4. So the root 2's just cancel. So straight away I get root 10 plus k squared equals 4. Well, to get rid of a root, you can do the opposite, which is squaring. So if I square this side, I get 10 plus k squared. If I square that side, I get 16, 4 fours. Quadratic, it's not even a quadratic. I can just take the k squared there and do 16 minus 10, which is 6. And that means that k equals the square root of 6. So what was the question? Find the value of k where k is greater than 0. Okay, it says k is greater than 0, so k is just root 6 as k is greater than 0. In other words, not minus root 6. And we're done there. This has been Mr. Clelland from Clelland Maths. This was your Ultimate Higher Maths Prelim Special. Hopefully you found this useful. Remember, I've got our app. We've got our members only live stream on Sunday. If you missed it, don't worry. It'll be on there for you if you're watching this after the fact. Just join now. And hopefully you have a great Christmas and the prelims are good for you. And I'll keep making lots of content for you. Take care, stay safe, and I'll see you soon.